Number 39. We have a circle and a right triangle, and the triangle is inscribed in the circle, and we know the diameter of the circle is 75.2. We also have this angle right here that is 38.3. Alright, so what can we do here? Well, we can start off by recognizing that if you have a right triangle inside of a circle, inscribed in a circle, then the hypotenuse of the right triangle is also the diameter. So this hypotenuse, since this is a right triangle, is also a diameter. So this length right here is 75.2. And then once you recognize this, it's just a very basic trigonometry problem. You have an angle, you have an unknown side, and you have a known side. So we can just use trig identities. So we have the opposite and the hypotenuse. So this is a job for sine. So sine of 38.3 equals the opposite side over the hypotenuse. So it's x over 75.2. So x is 75.2 times the sine of 38.3 degrees. We go to our calculator, make sure we're in degrees. We are not in degrees. Now we are. So 75.2 times the sine of, I already forgot the angle. 75.2 sine of 38.3. And we get a length of 46.6. That one's pretty quick, but the only thing you have to recognize is that the hypotenuse is the same as the diameter. Alright, let's move on to number 40. We have right triangles. So we have this right triangle and then the longer right triangle. We know these two side lengths, and we also have this angle of 0.524 radians. So it looks like we're going to switch back to radians, but that's okay. The first thing I'm going to do, and the first thing you should always do on these kinds of questions, is just look for sides and angles that you can find. And then usually those sides/angles will show you how to do the rest of the problem. So I'm going to start off by finding this hypotenuse length, because once I do that, I will have more information about this triangle. So to find that hypotenuse, we just have to use the Pythagorean theorem. So a squared plus b squared equals c squared. So we have the square root of 79.9 squared plus 87.6 squared. And so the length of that side is 118.565. So this is 118.565. I might write that in red, or at least the decimal. 118.565. So now we have one more piece of information about this triangle that we're trying to find the long side of. So what other information can we get? We can solve for this angle, which in turn will help us solve for this angle. So let's see, this angle will just be, let's see, if we use opposite and adjacent, tangent of that angle theta will be 79.9 divided by 87.6. So to find that angle, we first have to switch this to radians, and then it's just the arctangent of 79.9 over 87.6. So it's going to be 0.739 radians. And then if we want to find this angle, which is actually what we want to find this angle, it's a linear pair, so together they will equal pi radians. So to find that angle, I can just do pi minus this right here. So looks like we get 2.402 radians for that angle. 2.402 radians. All right, let's see. Let's see what else we need. Oh, okay, so here's something. We have this angle and the opposite side. So 0.524 radians and the 118.565. And we have this angle, and we're looking for this side. So we could just use the law of sines. So sine of 0.524 divided by 118.565 equals the sine of 2.402 divided by x. So if we solve for x, this will be sine of 2.402 times 118.565 divided by the sine of 0.524. So we do that in the calculator real quick. Sine of 2.402. Let me get my fraction bar. Sine of 2.402 multiplied by 118.565 divided by the sine of 0.524. This should give us the side length of 100, so rounding to 3 sig figs, 160. This side length right here is 160. Alright, so if you have any questions from other tests, make sure to leave a comment and I'll make a video with a solution. With that said, if you enjoyed the video, leave a like and subscribe. This has been Investigative Math, and I will see you next time.